All right, we're just missing a couple. We'll go ahead and get going. I'm straight up with you guys. You guys have probably spent more time on this unit than I have at this point. I was out a day last week on Friday, and Thursday I actually went home early. My test results came back last week confirming that my bone marrow transplant has officially failed and that my leukemia is back and it's back with a vengeance. So the test from the first of the month in October showed there was a small amount of leukemia in my blood cells, cancerous blood cells. And then we redid the test 2 weeks later on the 15th, and it had grown by 16 times as much. So it grew 16 times in 2 weeks. And that was back on October 15th. So I don't know how much it's grown to at this point, because we won't be testing that again anytime soon. We got to start a method of treatment. So I went to my oncologist on Friday in a lot of pain because when the leukemia is acting up, it makes joints ache. And so like this morning, my back and hips are hurting just because I outslept my pain meds. I slept like 13 hours last night. So it takes a lot of energy when you have leukemia because those cancerous blood cells do not help you have any energy. It just kind of zaps you. So with that, I'll be starting a chemo pill sometime soon. They're working with my insurance now to get that approved. As my doctor said, it's not a $10 prescription; it's a $30,000 prescription. So you got to work with insurance to get all that going. So I do not have a chemo pill yet, although that's what we agreed to on Friday is going to be the treatment course at this time. And if that chemo pill works, that'll be great. That will be the least invasive. I'll still be able to come to school, function, have a life, all that good stuff. If the chemo pill does not work, then I will end up in the hospital and having another bone marrow transplant and everything that goes with that, which last time there's a lot, which means moving to Little Rock for 3 months and having to be within 30 minutes of the hospital all the time because the bone marrow transplant leaves you with zero immune system, zero zilch. You have nothing. So a cold can just totally wipe you out, so they want you at the hospital immediately. So you have to stay very close to the hospital all the time, 24 hours a day. So we're hoping we don't have to get to that point. We're hoping this chemo pill does its job and that it arrests this leukemia and starts flushing it from my system. But first, I got to get it going, got to get that done. I will be going in sometime this week to have a biopsy done of my bone marrow, which is just as much fun as it sounds like. They go take a needle and they crunch through your bones to get to the middle and pull out some bone marrow. So that way they can put it under a microscope and examine the bone marrow itself. So that will be happening sometime this week. I do know that one day next week, I don't know which day yet, but I will be going to Little Rock to meet with my oncologist down there. So I will be out a day next week. Again, I don't know what day, so I don't know if it's going to affect this class or if it's going to be an A-day. And I'll let everyone know when I figure out what day I'm going to be out next week. But I may be missing some days from time to time now just because of reactions to the chemo or just pain or just appointments or who knows. But we're gonna do the best we can to be functioning and moving and not just sleeping all the time, because that's all I really want to do when this is bad. So we're treating this thing right now. We're just treating the symptoms. So I've got some new pain meds this week because last week I couldn't function at all. Thursday and Friday, it just got so bad I couldn't hardly move. So I've got some new pain meds that do much better if you don't sleep so long that they wear off, which is what I did last night. But it'll be kicking in here soon. I took them over half an hour ago, so I expect pretty soon all the aches and pains be in good shape, and we'll be back to going. But with that, I just let you guys know that because I have not had very much time that I have looked at your lessons. So we're going to kind of go through this together this morning. I know last week we had the SAT, PSAT on Tuesday, so we didn't have class at all. I've looked. Most of you guys have done the lessons from last week, did very well. That's good because I just haven't had the energy to go back do those myself yet and put a video together on that. But I will, if need be. I will go back and find some time and energy to do that. But this morning I do want to look at 404 and 405. You have 404, 405 A and B. There's an A and B to 405. B is a grade that counts for the semester. It's a evidence of learning grade for B. It's a good assignment. So there's no new lesson for B. It's the same as lesson for A. So we don't have a different lesson. It's just a different assignment. There's a part A multiple choice as usual. Part B requires some more work. So let me put up on the screen my camera. We're going to talk about the definitions of trigonomic functions of any angle. I know we were working with acute angles before, with the triangles, with acute angles. Now we're looking at any angle. So we have this angle here. So let theta be an angle in standard position, and xy is a point on the terminal side of theta. We always started here and it goes this way. So theta starts from the x-axis and xy is a point on the terminal side. And then we have r, and r will be this length right here. R is equal to the square root of x squared plus y squared. And r cannot be 0, or else you do not have any angle at all. You can think of r as radius. If this was a circle and that was like a radius to a circle, you can think of that. What you'll notice that since r is calculated to be the square root of x squared plus y squared, that comes from the Pythagorean theorem. Because if you look at this xy, if we brought this straight down, we're going to call that straight down and straight across. This is that side of that triangle is the length of x, right? Because that's the x, and this is the length of y. And if we wanted to find, that would make a right triangle. And if we wanted to find the hypotenuse, it'd be a squared plus b squared equals c squared, right? So if we take x squared plus y squared and take the square root of that, that will give us the r. That will give us that length of that side. So that's where that comes from, is the Pythagorean theorem, that we can make an imaginary right triangle from that point on our angle. So with that, we can define all the trigonometric functions. So let's list them out. So sine of theta equals y over r. So whatever y is over r, and r, here I'll label, this would be the r, the length of that, right? So y over r is sine. Cosine of theta would be x over r. All right, when we think about it, that's really adjacent over hypotenuse if we make this imaginary right triangle. So we can see how this works using just that point in this r. It comes from this imaginary right triangle. Y would be the opposite. Although we're talking about this outside angle instead of the inside angle, but this works. The tangent of theta would be y over x, and x cannot be 0. All right, x cannot be 0, but y over x. When we look at the cotangent of theta, it of course is x over y, and the y cannot equal 0. The secant is going to be r over x. X cannot be 0, and the cosecant is going to be r over y, with the y not equal to 0. All right, so with that, with a point making an angle for theta, we can calculate the sine, cosine, all the 6 trig functions using that by creating this imaginary right triangle and still using our functions as we're used to. So r would be the basically the hypotenuse when we create that, but it's just going to be the square root of x squared plus y squared. So if you have the point, you can calculate the radius or the length of that terminal ray to that point, wherever that is. So let's move on a little bit. So it gives an example of this is the point 1 square root of 3. Our text has an example that the radius would be 2 because you got square root of 3 squared is 3, square root of 1 squared is 1, square root of 4 is 2. So that would be your r, and you can fill all that in. Let's see. I'm going to put this up on our screen from our lesson. All right, if we look at this graphic here. So since we're referencing the point on the terminating side, we can determine from the angle what the sine of each trig function will be. Because we know that over here in quadrants 2 and 3, the x value is going to be negative. And in 3 and 4, the y value is going to be negative when it's below the x-axis. And we know r is always positive because it's a length. We're calculating the distance. So for an angle in the second quadrant, right here, theta, we would have a positive sine value, and then cosine and tangent would be negative. All right, because the sine value would use the y and the r, and the y and the r would both be positive there. Y is above 0, it shows us. And r is always positive. So we expect a positive sine value, but cosine and tangent both use the x value. And so since they use x value, you're going to have a negative in that. So that's a handy little reference in knowing if your value should be positive or negative just based on where your angle ends up, which quadrant that ends up in. So let's go down here. It gives you your check your answer stuff. So you can try some of those where it gives you just the point and wants to know what's sine, cosine, and tangent. So just having that point. So you calculate the r and then use those 6 formulas we just talked about. Let's talk about reference angles. Those are big because if we looked at what we did here, we made this right triangle that's actually not using the angle theta, right? It's the theta was the big angle, and we made a right triangle with the rest of it. But that's because we can have reference angles. See, a reference angle is the acute angle formed by the terminal side and the horizontal axis. So see, we made an angle like this first graphic right here. The reference angle would be the other angle that completes it to the x-axis. So it'd be 180 degrees minus whatever our first angle is. If this was 135 degrees theta, our reference angle would be 45 degrees. All right, so there's a lot of similarities in there between the angle and the reference angle when it comes to the sine, the cosine, and the tangent, because we were able to use all of those functions. It just may change the positive and negative because it's in the second quadrant rather than the first, but we're using the 45-degree reference angle. In the third quadrant, you would subtract to get it back to 180. So you take theta minus 180, and that would be your reference angle to the closest x-axis. It has to be an acute angle. The reference angle is an acute angle. So when you get to the fourth quadrant, it's the acute angle that brings it up to the x-axis on the right side, 360 minus the theta. We'll get there. So if you measure the angles, if you measure the angles in radians, then of course you use pi and 2 pi rather than 180 and 360. So all of that. So it has some determine the reference angles. I got another check your answers in there also. So, all right. So this is a little cheat sheet. You can put your notes. One other thing is ASTC. ASTC, if you remember that. A means all of the trig functions are positive in this quadrant. So when you see the A in the first quadrant, all of them. S means only the sine is positive. T is only the tangent's positive, and C is only the cosine's positive. So that's a nice little quick cheat sheet to help you remember whether or not your sine, cosine, tangent should be positive or negative using this ASTC. ASTC. So however you need to remember that to help you go. If you want to go clockwise, think of ACTS, AACTS. As long as you remember which quadrant each letter represents, that's fine. You just have to remember which letter it represents, and that'll help you remember whether or not you should have a positive or negative answer with that ASTC. So, all right, it has some examples there you can go through. Lesson 404 actually has the same textbook pages as 403, so we don't add any of the textbook stuff on there. You can go back to 403 and look at that. It just expands on what we had in 403 and gives us some more work with that same text. But this is a new summary for 404. Let's go over and look at 405. Okay, 405, lesson summary right here. This is looking at the graphing, right? So basic, just sine and cosine. So the graph of the sine function is commonly called the sine curve, and these repeat infinitely in both directions. And they talk about its period. Its period is 2 pi. That means after 2 pi, it just repeats exactly the same thing over and over and over and over. And the range is from -1 to 1. All right. And then the graph of cosine is the same, except for it is offset by pi divided by 2. So it's the exact same graph as sine. You just move it over, add pi divided by 2 to the x, move everything to the right, and you'll have the exact same graph as the sine. But notice here, like when x equals 0, where the sine is at 0 on the left one, on the right, the black one is the curve which shows cosines at 1, right? Because on the unit circle, that point that's on the x-axis is 0, 1. So the sine is at 0 and the cosine's at 1. But we call this a phase shift. If you phase shift sine by pi over 2, you get cosine. So this gives instructions on your calculator. Hey, you can view that. So you can type all this good stuff in there. So if you have a graphing calculator and would like to do that, it does have the instructions on how to help you look at that on there, which is a very useful thing to do. So let's go down here. The key points. We certainly want to talk about the key points in a sine or cosine curve. And let's see if I can make this any bigger on the screen. Yeah, there we go. We'll get this a little bigger. Okay, so the key points, 5 basic points in a single period, a single phase. These are the maximum and minimum, the x-intercepts, and the y-intercept. All right, so this also helps when we do transformations. But let's look at these. So with the sine curve, which is on the left, sine's on the left, you have the intercept at 0, 0. That's where it starts. It will intercept the x-axis again at pi. So at pi, 0, and then at 2 pi, because that is one full period of the sine graph. So it starts at 0, goes to pi, 2 pi. It intercepts the y at 0. And then our maximum comes at the value pi over 2, 1. Think about this as a circle. If we look at this on the circle, the unit circle, this is on the x-axis, this on the x-axis. This is at the 90-degree mark. Pi divided by 2 is at the 90-degree mark, and that's when the value of the y is up to the 1. The unit circle is at the very top point of the circle at pi divided by 2. So that ends up our maximum. We call that the quarter period, the half period, the 3/4 period, because the quarter period, you're a quarter away around the circle when you hit this maximum on graphing sine. You have the other intercept. The minimum is going to be at that bottom point of the circle. That's 3 pi divided by 2. If we're using radians to go around, it's 270 degrees, or 3 pi divided by 2 in radians, because we deal with radians a lot when we're talking about pi and all these trig functions and graphing that. And so the full period brings us back to the 2 pi 0. So you need to think about the y-intercept, x-intercepts, maximum, minimum when we're talking about graphing these trig functions. So if we shift over to the right side and look at cosine, it's got a y-intercept of 1, and it intercepts at the pi divided by 2 and 3 pi divided by 2 points. Pi divided by 2, 3 pi divided by 2 is where it intercepts the x-axis. And then the minimum right here is going to be at the half, pi. It's going to be at -1. Pi -1 is the half. And then the maximum at 2 pi. That's what's going to have its largest value. So it's looking at the x-axis. Remember, the cosine looks at the x-axis. So we're looking at the left and right sides of the circle. The biggest part of the circle is over going to be on the right quadrant, and the first quadrant over there on the right. And that's at 2 pi or 0. So that's when it's at 1. When it gets to the other side of the circle on the left, that's when it's at the -1, because that is at pi. So that's the important key points on a sine or cosine curve. So the standard form of equations can be expressed in the following: d plus a. Let me shrink this down a bit so we can see more of this information. So when you look at this, d plus a sine of bx minus c, a is the amplitude of the curve, and that determines the vertical stretching or shrinking of the curve, because we could put an a out in front of this and stretch it out to where it's longer than 2 pi is one period, is one phase, or we can make it smaller than that, so we can change the amplitude. The value of b determines the period of the graph right inside there with the x, and determines the horizontal stretching or shrinking. For a positive value of b, less than 1 stretches it beyond the 2 pi. The value greater than 1 will shrink it less than 2 pi. So this is, the amplitude was the range. That's going to take it higher than 1 or -1. And then the b will make it stretch out the longer period, longer than 2 pi or less than 2 pi. And of course, if b is negative, then the value such as sine of -x equals negative sine x, and the cosine of -x equals cosine x. So C is the phase shift. That determines a horizontal shift of the curve along the x-axis. Just like any other transformation, when we were graphing x squared or parentheses x minus 1 parentheses squared, the -1 made it shift to the right 1. This would be the same thing, although you generally use radians. That C would a lot of times be a pi divided by 2 or a 3 pi over 4 or some value in radians rather than in degrees. And that'd be a horizontal shift right there. And then D is the vertical shift, the value of D. They put it in the front, plus D, but think of like in these graphs, when we put a +3 at the end of a graph, that just raises it 3 or lowers it 3. Same thing, they're just putting it at the front of the equation instead of the end. You might see it at the end of the equation. You could see the sine of theta +5 at the end, which would just raise it a value of 5 on the y-axis. So this is the standard form for that, and what those different numbers do and playing into the graphing of that. So the graphs of y equals a sine bx minus c and cosine bx minus c have the following characteristics, with b greater than 0. Amplitude will be just the absolute value of a, and the period is 2 pi divided by b, right? So whatever that is, if that's smaller than 1, it's going to make it a larger period than 2 pi, or larger, or if it's larger than 1, it's going to be smaller. And then we can find the left and right endpoints of the one cycle by solving bx minus c equals 0 and bx minus c equals 2 pi. So this gives you some example problems where you can check your answers, trying to determine the amplitude, the period, and the left and right endpoints. And then it talks about graphing by hand. So if we have these things, we know the key points starting out. So is it a link? That is a link. Okay, I've got a link there. I don't know if it's working. Okay, it doesn't work. I need to check what that is and see if I can't make that something you can access, because it's saying invalid session. We link on that. So I generally set those up as a Google Doc, so I'll fix that. So once we have found the amplitude, period, and phase shift, which we just figured out how to do, we use the key points listed above. It takes you back and shows you this. That's what the key points, that's what that link is supposed to take you to. This part that's in yellow right there. So it's just supposed to take you to that. That's what this link was supposed to be. It says, look at y equals 2 sine 2x minus pi over 2. It says the amplitude 2, the period's pi, the phase shift is pi over 4. So to graph it, we start by dividing the period by 4. Instead of having the full period, it's divided by 4. So that gives us pi divided by 4 to help us find the coordinates of the key points. So you see, when they do a full period of this, It's a lot shorter than the 2 pi on this. So if you go through these instructions, it talks about you have multiples of the pi forward, the phase shift things to the second and the third, begins the beginning, minute, middle, and end of the cycle of the curve. Plot the maximum, you'll plot the minimums because you have those that you can calculate. And unless the curve is reflected, the maximum always occurs midway between the first and second x-intercepts, right? It is a very consistent graph. So if you can find the intercepts, your maximum and minimum should be at the midpoint of those. And then, of course, you can find the y-intercept by evaluating x equals 0. And you'll have this right here. So at the 2 sine, 2x minus pi divided by 2, your graph looks like this. So it says that there's examples in our textbook for more graphing by hand. Has some more test your skills and more test your skills, and then it gets into the text of all this. So all kinds of pages and pages of good stuff. So that is the 2 lessons we had to look. I want to look at the 405B while we're here. When you get here, there's not actually a lesson. This talks about your assignment, and then you turn it in on the assignment page, but this is the lesson page. It gives you the assignment. So here's your assignment. Respond to one of the following choices. So pick one in a word processing document. Your typed explanation must have at least 100 words, should be answered complete sentences. Just make sure it's a nice formal paper, right? So choice number 1 or choice number 2, either one of those. So in choice number 1, you describe each of the following properties of the graph of the cosine function, f of theta equals cosine of theta, and relate the property to the unit circle definition of the cosine. So you get the amplitude, the period, the domain, the range, and the x-intercepts. Okay, and then choice number 2, you're going to do sine. Same thing, but with sine. So here's what your response needs. You should have a discussion of the amplitude, period, domain, and range of whichever function you chose. You should relate each property to the unit circle. For example, if discussing the domain, describe how the domain of sine or cosine is based on the unit circle. You should have 100 words with appropriate grammar and spelling. Provide any source you use. If you use our book, if you use some website, right? Because it's fine to go out and get extra information to help you say what you want to say. So here's a rubric that you can click on that shows you. So it's worth 10 points. 4 points are based on this part of it, discussing this. 4 points based on relating the property. And then 2 just on the structure of it. Make sure you have your source and you've used proper sentences and grammar and kind of stuff. So that is the rubric I will be using to grade this. And then just save it and turn it in on there. So when you go to the actual assignment, it's just one of these pages to where you submit your work there. So that's what we're looking at with the 405B, and that is a evidence of learning grade. So 405B is something just a little bit more that really helps me know if you understand what we're talking about or not. And you guys are doing very well. So I don't expect this to be a big problem for you. Just hopefully some easy points for you to add to your grade. So, all right. Anyone have any questions? You have a lot of questions, right? But we don't know how to formulate them. So, all right, guys. I expect to be here Thursday. If you have questions, if you need anything, all of your grades are well above 70%, so no one's required to be here Thursday. But I will be here Thursday morning if you have any questions or anything. Otherwise, I'll let you guys go and have a great day.
Let's get out of here. Word to your multiples.